Okay. Before we begin with this idea of dividing polynomials, which we talked about we talked about polynomials, I think, the very last class. But remember the most generic form of a polynomial? This is hard to remember compared to other things. It starts with A. It has a little bitty x right there. Wait, no it doesn't. It has an x right here. We're missing two letters that are the same letter. Usually they have this little n right here telling you that's how many terms the whole thing has. Or that's actually it's got a better word. You know what n stands for? Starts with a D? Oh, okay, we'll keep going. Plus what? It is degree. Heck yeah. And then this one's harder to know. It's ax again, right? But instead of n, you know what they usually call it? N minus 1 for both of them. Just whatever n was, take away 1, and we're going to work our way all the way down to 0, right? What? We see this all the time. Okay, yeah, but because we don't usually write the variables. Usually we just write 8x to the 4th plus 2x to the 3 plus 4x to the 1. You know what I'm saying? Here, what's n? Here we have. Go look at your notes from yesterday. Is it at the very top? Charlotte? Very top. Dot. What is n? In this case, it's 4. In this case, right? N is the degree. What else we got? Plus. Oh, we do a big dot, dot, dot usually. Dot, dot, dot. A1, x1. A naught, x naught. Wait, there's no x naught. It's just A1. A naught. Okay, well. It's the same thing, right? It's the same thing. You don't need A2x2. You know A2x2 exists. Look, this is just it right here. It's just one of these long, see the blue dividend right there? It's just one of those. That's what a polynomial is. I could have just drawn an arrow straight down and we've seen an example of one. Look, that dividend right there, polynomial. Okay, now before we jump into dividing polynomials, I am going to ask us to divide, super basic thing. 2, big old divide sign, 1, 3, nope, 1, 4, 5, 2. That's fun. Yes. What's the first thing you do? What do you mean? How many times does 2 go into 1? 0. So how many times does 2 go into 14? 7. And then what do you do with that 7? 7 times 2 equals 14. And you write it down here. And then you do zoop, zoop. You know this is where this is going. You know exactly where this is all going to, right? 14 minus 14 is 0. Drop down the 5. Ooh, we're going to get a different little thing happening. How many times does 2 go into 5? But now we're going to go 2 times 2 equals, what the heck? What do we do with that 4? Zoop, zoop. You say 12? It's okay. You can say 12. Oh, it's going to be 12 in a little bit. But 5, oh, wait, do we do it in the color? What do we do here? Black? 1? 12? Got to get a new color. Make it blue. 2 times 6 equals, oh, look at that. And actually, I'm not going to give up on it quite yet. This 0 has a name. Oh, crap. I've never done this before. This is really cool. And you may have to do a little super long retrieval from last year, especially if you're in my class. Because I really tried to ingrain this thing in our brains that if you get a 0 as a remainder, what's the first thing you should go do in your brain or on the paper? If you get a 0 as a remainder, and this took the form more of, like, remember that synthetic division where you have like 2, and like 4, 8, 7, 2, drop, you had a bunch of math stuff here, and then if we got a 0 right here, what do we do immediately? What is a 0? Yes, we would write 2 is a 0, right? And zeros kind of tell you about what? Okay, yes, true. And factors, right? Now the factor here is actually x minus 2, right? But I've never connected these dots before. If you get a 0 as a remainder right here, what does that tell you about 2? This is really cool. This is the first time I connected this dot. It's not a 0 because we don't have zeros anymore, right? But it's one of those words that we just talked about. This is cool. I think I'm pretty pumped about seeing this. 2 is a blank. It is a number. I can't fault you for that. What? F. Factor of what? 2 is a factor of that, right? Which I think comes down to, we don't know what a factor is. We just know it's the x minus number type thing. What is a factor? Well, I mean, it does work out to that. What are the factors of 12? Okay. So what do those equal? What is another factor set? 1 and 12? So what does a factor mean? 2 numbers that multiply to make the number. Right? What 2 numbers multiply to make that number? 2 and that big number make that number. Very cool. So we got a factor. So if, this is just going to come back to play later. If the remainder is 0, you have a factor. Pretty cool. Pretty cool. All right, let's do this real math stuff now, okay? That was just for fun. That was to jog our memory. If you haven't done long division in a while, come to office hours and we'll do some 3rd grade math. Let's set it up. We're dividing the dividend, if I'm not mistaken. It's hard. These are hard to remember. The dividend by the divisor, which means we're going to put 4x plus 5 on the outside and 16x cubed minus 12x squared plus 20x on the inside. And I'm going to ask you the same question we asked about that one at the very beginning. What can I multiply by to get me the first term? You're saying 4x squared? I don't believe you. Let's go off to the side and check. 4x squared times, I've totally forgotten. Someone's going to have to remind me of what my divisor is. Distributive property. And we end up with, let you do it for a second. What did we do with the side, off to the side multiplication thing when we did it simple form? Not you, 4. Stop. Somebody else. No. What did we do with that off to the side multiplied thing like literally 5 minutes ago? Remember what we did for it up there? I think I deleted all that stuff. Dang it. I shouldn't have deleted it. I'm not asking you. No. Oh, no, it would take way too long. Back row? Someone on the back row? Any thoughts? I know how to do this. If it's like me coming to work to do something I know how to do, that doesn't make any sense at all, right? We take the number and we just go for subtraction. I forgot the thing already. 16x cubed. I'm very bad at this. I can just zoom out. And you know what that subtraction sign has to do to both things, because we're not just subtracting the first term, we're subtracting the whole thing. You didn't just subtract the 1 from the 12. You subtracted the whole 1 and the 2 subtraction, right? So we're going to go distribute the subtraction sign. Distribute the subtraction sign. And now we've got 16 minus 16. Zoop. And negative 12 minus a 20. And we drop it down. And we reset. And we do it again. How can you get from 4 to negative 32? So 4x squared times... Wait, no, that's not right. I was just copying up what was above. What did you say gets us there? Negative 8x times 4x plus 5? You're saying that's going to work out nice and neat? Be negative 32x squared minus 40x. They're going to work? Negative 32x squared minus 40x. I've made the most common mistake in the world. Well, not in the world, but for this type of problem. What have I not done yet? I haven't done a really important step. You have to subtract the whole thing, which does result in changing both signs. Negative 32 plus positive 32 is 0. And that's positive now. Yay. 20 and 40 is? I think we could do it one more time. Don't you? So I gotta get one more color. Oh, I'm out of colors. What the heck? Let's go pink. Pink too hard to see? That's fine. So how can we get from 4x to 60x? Oh, wait, I've made it. Yeah, the green one. And I just changed the color, which is even worse. This green one right here, right? I forgot to write negative 8x. Good catch. Thanks for stopping me before I went too far ahead. And now what someone else is saying is, hey, 15 works, right? 15 times 4x plus 5 is equal to... What? 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 Plus a hard math problem. So 60x. I should probably write plus 15 up here, right? First. Plus 75. You know what we have to do from both sides? Distribute a negative, also known as subtracting, but same word. So 60 minus 60 is 60. And, whoa, there's nothing above it. That means we're just left with negative 75. Now we've got to write an answer. 4x squared plus, minus 8x plus 15 plus negative 75 divided by, we got to pick the small one or the big one. The smaller one, the divisor. And we got ourselves a long division problem. Oh boy. The good news is we're doing one and we're moving to synthetic. So that was it for the whole class. You're welcome. I think if that's wild and impossible, you'll get some in the homework and it won't come up that much in class. I will let you know if it's going to be on a test, and you'll know like way ahead of time, hey, I got to go back and practice that long division stuff. However, with synthetic division, just what we do in class will lend to using it so much more that it's probably way more important. Pause. Questions? Comments? Concerns? Complaints? What's the word? Qualifications? Queries? It's a good one. I'm going to run out of words real fast, though. All right. Now we got to do the synthetic thing. And the synthetic thing is pretty much exactly the same thing. It's just way faster. But it's got to look like this. It's got to look like this. It's got to look like the way that we most often represent. You know what that word kind of is? It's a factor, right? But I'm going to tell you right now, that's not a factor. You know what that actually is? I messed up last class. We had to go back and correct it and say, actually, it wasn't a factor because we had a, I'm not going to tell you yet. It's a potential factor. We're going to check and see if it's a factor. But it is written exactly like we see factors all the time, right? So we're pretty much, in doing this, in dividing, we're checking to see if it's a factor. Kind of the same way if you divided 60 by 7, would you get a good, nice, neat number? 60 by 7. Nope, not a good number, so it's not a, there you go. We're checking to see if it's nice and neat. That's kind of the whole point of this. So the fun thing to know, what's the 0 associated with that potential factor? What would the potential 0 be? Oh, holy crap. I thought this was a gimme. Yeah. Oh, it's, yeah, I'm just going to write -7. I know. I know. Okay, well, crap. Fine, the potential 0 is x equals -7. Just more of a line. Oh, crap. There you go. There's the potential 0. So you know what part of that potential 0 we're using? You've done it before. -7, right? Backwards box. What? Little backwards L box in that -7. I think that's step 1, right? Is that step 1? Right, K for the divisor. That's the divisor. That's the K value. We flipped the sign. Write the coefficients now. Well, I guess that's these, right? 3. Oh, that's not a highlighter. We got ourselves a 3. 18. What? I don't even see a 0 in there. This is what I like to draw it as so I don't forget. Right? Something missing. A plus 0x squared. I'm just enjoying thinking about how hard this question. Here we go. This is fun. This is fun. Everybody reel back in real fast. This will get everybody. I found this today as I was cleaning out my closet or something. Let's see. Yeah. See, you know the number of times last year? Remember when I was always lying? Yeah? That's not no more. This is not a lie. Luke knows. Luke probably earned like $100 last year. No takebacks. $50, right? Okay, here's a fun question for me, I think. Just trying to get everybody's attention back in here is what we're trying to do. Yeah. What is that? But I can't phrase it too specifically or you'll just know. What is that 0? What is that 0? Specifically, what is that 0? Okay, but so that doesn't help me because you know what else is a coefficient? That 18, and so it's not a specific answer. Huh? It's not imaginary. It's real. 0. It's not. It's not. It's talked about today. This is where I think I lost everybody earlier today, and now I'm thinking, oh, this is a fun chance to see it occur. It's not a factor. Nobody's trying to get $50? Can't tell you that. No. It's not a whole. It's not a quotient. The whole thing's the quotient. No, the quotient's the answer. It is 0, but that's not worth $50. Dividend? A dividend? All right. Keep the eyes up. I'll try to come back for that $50 later. From earlier, really specifically for the thing that nobody liked, the 0 is technically A2. It's the coefficient A2 in that equation that nobody liked looking at. And you know what 3 is then? If you could, I'm not for $50, but what does that make 3? N, but in this case, N is A4, the fourth A. This is the third A that we have in the world. This is the second A that we have in the world. And the little subscript isn't telling you what number it is. It's just telling you, hey, this is the first A in the world, and this is the second coefficient of the world. It'd actually be better if there were C's. And sometimes we do use C's when we do exponential functions. If you've ever done that world, anybody ever done this is going to look really weird, but anybody ever done the C1EX world? What have you seen that for? Technically, it's not C. It's like X plus C or whatever. Or actually, no, I don't even know. But yeah. C is better because the word coefficient. We use the letter A. All right. Good try. That was a really good try. I was just trying to reel back to the beginning when I lost everybody at the beginning. Like right up here is when everybody went blank stares, right? And I'm trying to show you this is a real world thing. This is just a general formula with no numbers to say what's happening down below. The only reason they use A to the N is because at some point they can't be like saying A plus B plus C plus D plus E plus F plus G plus, no, this is easier. The N tells me exactly how many terms we're going to have down the line. Whereas if I said E X to the E, everybody would be like, I don't know how many that is. Let me count. A, B, C, D, E, right? It's a little harder for our brains to wrap around the numbers. So we got to put a 0 there for our A2. We got to put a -3 there for our A1. We got to put a 40 there for our A0. And you really remember the first step, which is the easiest step? You just little arrow, long line, right, the 3. Easiest step of the whole thing. This is where it gets a little annoying. But easy, I think. I think easy. You just can't zoom out right now. If you zone out right now, in 2 days, you'll be like, what are we doing so quickly? Because everybody's doing it real quickly and writing the answer right. So don't zone out right now. Though if you already did, I know. I don't control you. I don't know. We're going to multiply in this rainbow pattern, right? 3 times -7 is. We're going to write it right there. So we multiply, we write, and then what do we do with those two numbers? We add them. 18 plus -21 is, and I'm going to change my color. Cool? Now the green section. I guess I could have made that whole row red. -3. Now the blue section. Multiply. right? This is about to look really messy, but I'm trying to show you what our brains are doing if you haven't seen synthetic before. I'm trying to show you the pathway our brains are going. We're going left, right, add. So that's positive 21, right? Green time. Multiply. Whoa. Thank you. Negative 147. Add. Pop. Oh, I'm so dumb. We're not multiplying. Yep. Thank you. Negative 150. Last color. Shoop. Multiply. Shoop. 1050. Positive or negative? Positive, because that's a negative. I've just written over it so many times. Hard to see. So 1090. And do you know what that last number is called, just like last time? Your remainder. Say that sentence loud and proud. That means that x plus 7 is not a factor. Or, no. Well, it's not a 0. Negative 7 is not a 0. X plus 7 is not a factor. Well, I was just thinking now we just probably should write the answer. Okay. No, I was just thinking like, okay, well, we can't really do anything else. We would, at this point in our problem set, we move to the next number that we haven't tried yet in the long list of P over Q, TC over LC. But because we're not out doing that today, we are just going to say, okay, here's a thought. Here we go. Redemption shot. What's this negative 1? If that's the remainder, what's the next one in line called? Cool. Not for money, just for redeeming your dignity. Which means 21 is our yeah. Wait. It's A2 or A1. I've forgotten. I need yesterday's notes. Wait, what's the farthest right? It just depends on where they start. I don't know where they're starting. A1 has an X with it? Okay, then it's A1. Did you say A1 or A0? Nice. A2, A3. You don't have to know the A thing. I'm just trying to show you why that equation thing is even a thing. Why the whole thing where everyone's like, we didn't learn this, is actually happening. You just don't see it happening because we give them real numbers. So that's X, that's X2, but because there's no sign here, you know where you should probably put it in there? Plus sign. And that's our answer. 3x3 minus 3x2 plus 21x. I'm running out of room. Minus 150 plus 1090 over x plus 7. That took up a lot less space on the paper, right? Could have done it the old way. No, it did. What do you mean? Did it not take up any space on yours, hardly? Took up the full thing on his. What everybody else got? Did you do it? Oh, I'm done. So I thought that was the front, and I don't know why. I just didn't see the writing at all on the bottom because because you already did the next one. So cool. Good job. Nice. Yeah. Alrighty. Here we go. They gave us the area of a rectangle, and they gave us the width of a rectangle. And I bet there's a formula that has those two things in it. Area equals Length times width. And you know what the problem asked for? I'm still zoomed into it. So how do we get length by itself if they've given us this, or they didn't give us, you just knew this formula? How do we get length by itself if we knew this formula? Divide by, dubs. So length equals area over W. That feels like a synthetic division problem to me. You know what's going on the outside? No width. So we got, well, here, I'm going to write it out just to be cool. 3x3 plus 14x2 minus 23x plus 6, and then x plus 6. Good chance to point out if we're missing anything. If we're missing any A2s, or we're not. Okay. 3, whoops, near. Actually, I think we are missing one of these. You tell me. Well, there's a 1 right there, right? What about this one? What's supposed to be there? If we're following the pattern, what the heck? I'm just so confused. Heartbroken. What? Do you know this? What's supposed to be there? Or it seems like a 0 should be there, but what's 6 to the 0? No, it's not. Yeah, and that's not 1, it's 6. So it's a 1? But we've already got a 1. But we've already got a 1 right there, that right next to it. This is very confusing. No, we're not. We're looking at the exact depth. I'm looking right at depth. You know how you said there could be a 1 there? See that green 1 right there? I posit there's a green 1 in all the other ones. It's right there, and right there, and right there. Well, no, it's not right there. It's right there. Right? 3 to the 1, 14 to the 1, 23 to the 1. So what are we missing? Follow the pattern. X to the 0. What's x to the 0? What is... Actually, the real reason I have $50 is because I couldn't find my wallet this morning, and I was like, I got to get gas on the way out, but it was underneath the seat, like tucked in. So that's why I had that one. What? Sounds like you don't need it. No, I really need that. No, I need to. I did try to find them online, though. I couldn't see them. That's not nice. Yeah, x to the 0 is 1. So does that do anything to the 6? So that's why they just leave it off all the time, right? But it's there. It would be really weird if they just had a not pattern formula. There's a pattern to everything. It's just it's really cool to point out and see. If you were to add one more the other way, we start getting into real dangerous waters with rational functions and stuff. If you were to add one more, so you have 6x to the 0, right? If you were to add one more, like 7x to the negative 1, life gets crazy, right? Because now you've got that, which means you could go all the way across and get a common denominator and throw this whole thing out of whack. All right. Sorry, we got 5 minutes to get through this. What goes in the box? Negative 6. What goes not in the box? Nice. All right, this is going to be fun. I have a good idea. Drop down the 3. Rapid fire, starting with Wesley. Go, Wesley. Yep. Marjorie. It's okay if you don't know. If you have to, I'm not saying you. I'm saying if I get to somebody and you freak out, just pass. Just say pass. I'll just take off 1 point for everybody that passes from everybody's last test. Everybody? Yeah, so like if 4 people pass, everybody just loses 4 points on their test. That seems pretty fair. I'm just kidding. You can pass. If you want to pass, you can pass. But next number? There's no shame in learning. That's what I'm saying. Next number that we got going on. Oh, got you. Positive or negative? Cool. That's my most common mistake is I just screw up which sign, and then I look back and I'm like, oh, crap, I got to go back and fix that. Nice. Nope.
Yes. 3 is it x cubed for 3x cubed? Or
Oh yeah, it's fine. It's fine. I always start on the right. Start on the right.
okay. So that's the remainder.
That's constant. How much x?
X squared. Oh, what?
Oh, dang it! Hang on. I should have done the dotted lines. No, I went like this. Oh wait, I thought there wasn't a minus sign there. I forgot there was a minus sign there. That's kind of it, right? So the answer is the length equals 3x squared minus 4x plus 1. And the width is what they gave us. And how could you probably check your work? And you should get back the? Absolutely. What I missed that I wanted somebody to say, as soon as I boxed that remainder, and I already knew this because yeah. As soon as I boxed that remainder, which was somewhere around here, the only step, and it's not a rule, you're not going to lose points for not doing it, but it's really helpful to do this. As soon as you box the remainder and call it 0, not if it's not 0, but if it's a 0 remainder, zoom into this little black square, or this little backwards L square, and write is a 0, and then you know what the literal next thing I write is? X plus 6 is a factor. And then I keep going with whatever I was doing. You write the rest of the answer. You write the rest of the parabola or quadratic that comes next. What's wrong? Don't laugh. It's a math class, not laugh class. What? I did. All right. Mic drop.